Now, in this question is asking that for the solution of the gases WXYZ in the water at 298 Kelvin, the Henry law constant KH are 0.5, 2, 35 and 40 kilobar respectively. The correct plot for the given data is. So what he has done, he has drawn the graph between the partial pressure and the mole fraction of water, right? Now we know that lesser will be the value of Henry law constant KH, higher will be the solubility, higher will be the mole fraction of that particular gas in water, right? So let's start the solution. So the solution. Now we know that by Henry law, the pressure of the gas is equal to KH and mole fraction of gas, right? Okay. We can say that the pressure of the gas will be equal to KH 1 minus mole fraction of water. I am representing the mole fraction of water by XW, right? Okay. If we further solve it, we will get the pressure of the gas is equal to KH minus KH XW, right? So our variables are partial pressure of the gas and mole fraction of the water. So what we can do, we can compare this equation with the equation of the straight line. So equation of the straight line is y is equal to mx plus c, right? Okay. Now it means that the value of m is minus kh, means the slope will be negative. If the slope is negative, let's see the graph. Here the slope is positive, that's why it can't be the answer. Here also the slope is positive, it cannot be the answer. And if we talk about the next two curves, now we have to choose the answer from these two, right? And if we compare the value of KH in both the graphs, then we can say that our option will be option number 1. So answer is first, right? Let's move on to the next question. Well, in this question he is asking if P is the momentum of the fastest electron ejected from the metal surface after the irradiation of the light having wavelength lambda, then for 1.5 p momentum of the photoelectron, the wavelength of the light should be, and it's given that assume the kinetic energy of the ejected photoelectron be very high in comparison to the work function, means we can neglect the work function. Let's solve the question. So the solution will be now we know that energy of radiation minus work function is equal to kinetic energy. This is for photoelectric effect, right? Now what he is saying? He is saying that work function we can neglect. So we are neglecting the work function and we will get the equation E is equal to KE, right? Now after neglecting E naught we are getting this, and E is equal to half mv square, right? Or you can say that E is hc by lambda, that is equal to half mv square. Now what we are doing, we are multiplying m on both the sides. So multiplying by m, so we will get, our left hand side will become m h c by lambda is equal to half m v square and m square, right? So this we will get, and we can say that this is square of the momentum, and 1 by lambda is directly proportional to p square, right? And for the second experiment, say it is 1 upon lambda dash will be proportional to 1.5 p square. Now it is given that, here it is given, in the second experiment it is 1.5 p. So now we can divide these two equations. So after division we will get lambda dash upon lambda is equal to p square upon 1.5 p whole square, right? And it will be equal to lambda dash upon lambda is equal to this p square, and p square will get cancelled, and 1.5 we can write it 3 by 2 whole square, right? And this lambda dash upon lambda is equal to 4 by 9, right? And if we further solve it to find out the relation, the wavelength of the new radiation is 4 by 9 lambda. So 4 by 9 lambda is the answer. Let us check in which option it is given. It is given in the option number 2. So the correct answer is option number 2, right? So let's move on to the next question. Well, moving on to the next question. In this question is asking fructose and glucose can be distinguished by. Now there is a test which is called Selivanov test, and this test is used to distinguish between aldoses and ketoses. So to distinguish between aldose, the carbohydrates having the aldehydic group, and the carbohydrates having the ketonic group. So this test is used. So our answer will be option number 2, right? Let's move on to the next question.